Okay, hi everyone. This is going to be our lab demo for the metric system and microscope lab. So you'll have to bear with me. I'm doing this in my office / playroom at home, but I have everything that we need, so it should be fine. So as I said in the, let me turn this way so you can see me a little bit better. As I said in our class meeting, which was yesterday on May 21st, there is a recording for that that's posted on Moodle in case you missed it. You will need the PDF that I posted under the metric and microscope lab, or also in the assignment as well. You need to have this printed out or on your computer and have some sort of software where you can fill in directly into the PDF. Right, so you can handwrite on it as I'm going through the lab, or you can use a software like Kami, K-A-M-I, or you can use like Adobe, Adobe Pro or something like that where you're writing in, okay? And then you're gonna be submitting a PDF of basically of this entire lab as your assignment, okay? There is also another assignment before this, or that's kind of due at the same time. You'll see on Moodle that just says metric system assignment. That is of a different handout. It's all clear on the assignment. It's just for extra practice of doing conversions, okay? I talked about that and reviewed that a little bit again in our class meeting yesterday. That recording, again, from May 21st is there if you need it. So I'm not gonna spend time going through any explanation of doing conversions. Now, I did a little bit, like I said, at our class meeting. There are also many resources on the internet that you might find helpful, like through Khan Academy. Also, if you need help with the conversions, the metric conversions, please email me and we can set up a time to go over them independently, okay? So I'll leave it at that. As you go through this lab, you're gonna be practicing those conversions anyway. All right, so with that said, let's get started. So again, if you have to pause as you move through, that's fine. You need to make sure you have the lab, that PDF, in front of you, okay? I'm just gonna be referring to the page numbers, essentially. I'm not gonna probably pull it up on the screen because I think it's gonna be too confusing for me to be toggling back and forth. I will be obviously zooming in on what I'm doing and telling you guys what the measurements are and things like that. Also, when we get to the microscope part, I will be using my phone video so that you guys can actually see what I see in the microscope, okay? So like I said, I'm not gonna pull this up and share my screen and show you exactly where I am. I'm gonna tell you, based on the page number and on what the question says, okay? So it's up to you to be following along. All right, so let's get started. And so I'm starting off, the first page of the lab. It's laboratory 2 in your lab manual on page 9, just in case you have the lab manual. I'll leave it up to you to read that introduction. It's really just talking about the microscope and how we section things to actually visualize them in the microscope. Now, if you flip to page 10, that's where we're gonna start off with the lab. So I'm gonna sort of flip my camera and kind of try to zoom in here. And I'll pull things up to the camera as needed, okay? So, all right, so like I said, we're starting off on page 10. The first part of it at the top there is, again, just a little introduction to the metric system. That table 2.1 sort of puts together some common units of length, okay, and shows you how they differ by certain factors. So for instance, if you look at table 2.1 and you look at the unit there on the left, so the first one says meter, okay, and obviously meters, a meter, 1 meter equals a meter, right? And then if you look over to centimeters, there are 100 centimeters in a meter. If you look over at millimeters, there are 1,000 millimeters in a meter, okay? And then you can follow along. So if you go down to the next one for centimeter, it's now gonna say, well, how many meters are there in a centimeter? Okay, so now that's gonna be 0.01. It's a factor of 100, so it's 2 decimal places, but now it's getting smaller because meters, right? And I don't have a meter stick, and I'm sorry, I wish I did. A meter is about this long, right? There are 100 centimeters in a meter. okay? So if I ask you, if we talk about 1 centimeter, right, which is like this, how many meters, which are like this, are in 1 centimeter? It's a fraction of it. It's a decimal, okay? So that practice handout on the metric system talks about, you know, determining whether you have a smaller unit to start with, and then you're moving to a larger unit, right? Or if you're going from a larger unit to a smaller, and that's going to dictate whether you move that decimal place to the left, right? Meaning you're going to end up with a, you know, a decimal, right? Like 0.01, for instance, like I just gave that example, or if you're going to move your decimal place to the right where you're adding zeros and that number is going to get bigger. Okay? So we need to practice this on their own, on your own. So to be honest, me standing there and lecturing about it, that doesn't help, right? So if we were live, I would have you guys coming up to the board and doing things and practicing on your own. So it is up to you to do that practice on your own. With that said, if you need help, we can one-on-one do some problems like that. Okay, so it is your responsibility to tell me if you need that extra help on that. All right, so like I said, as we move through this lab, you're gonna be doing conversion, so you're practicing it anyway. All right, so we move on from there. So where I am now is I'm at experimental procedure for length, okay? And that's still on page 10, right? And so basically, it's asking us to measure, okay? Measure something, and I'm going to use, so I told you I don't have a meter stick, but I have this, and I know it's backwards. I have this ruler, which is 15 centimeters, and then the little tiny lines that you see in there, so you can see that these little tiny lines in this metric part down here, these little tiny lines are millimeters. You can see the 1, it's kind of upside down, but that's 1 centimeter, 2 centimeter, 3 centimeter. Like I said, it goes up to 15. All those little smaller lines in there are millimeters. There are 10 millimeters in 1 centimeter, okay? So this is what I'm going to be using to measure. All right, so the first one says obtain a small ruler, right? How many centimeters are represented? I just told you, okay? I just showed you there are 15 centimeters. And I just explained how many 1 centimeter equals how many millimeters, okay? So you need to be filling in, like I said, you're filling in this lab completely as we move through, unless I tell you we're skipping something, okay? So if you have to pause it and fill it in, that's what you do. I'm not gonna kind of pause and give you time. You can pause the video. All right, now it then asks you to do more conversions in number 1, okay? So make those additional conversions. All you really need to know is what I told you, that this is 15 centimeters, okay? In its entirety, okay? All right. Now, number 2 asks to measure the diameter of this circle. So I'm going to measure it, and I'm going to tell you what that measurement is, and then you guys can move through and do those conversions, okay? On your own. Again, pause it, do whatever you need. So I'm going to measure this, and I'm going to call it 3.7 millimeters. I lie. 3.7, and wants us to measure it, wait. It wants us to measure it in the millimeter. Okay, so in millimeters, it is 37 millimeters, okay? 37 millimeters is what you're putting in that first slot there where it says millimeters, right? MM. Then it's asking you to convert it into micrometers, and then asking you to convert it into nanometers, okay? So you guys need to do those conversions and fill it in. The only thing you need from me is that measurement, which is 37 millimeters. All right, so, and it gives you an example how to convert, right? You can basically, you know, you do this stuff in chemistry, you've probably done it before. You know, you can set up a sort of dimensional analysis type of problem where you make sure your units cancel out, okay? So as long as you know how many, you know, say for that example there, how many micrometers or microns are in a millimeter, you can easily figure that out, okay? All right, moving on to page 11. Now, it says to get a meter stick. I told you I don't have a meter stick, but that's okay. It tells you 1 meter equals 39.37 inches, okay? So 1 meter is about 1 yard, great. just so you guys kind of know, and I kind of showed you what it looks like. Now it's asking you how many centimeters are in a meter. You don't need a meter stick to figure that out, right? I already told you that, and it's also in that table, and you can find it out other ways, but here's your meter stick, right? There are 100 centimeters in a meter, all right? So you guys can fill that in, then it asks you to do another conversion, right? So follow that along. Now, number 4 asks us to use a meter stick to measure the distance of 2 long bones. Okay, I don't have those long bones. I don't have a meter stick, but it doesn't matter. You can use the example there. So it says, if the bone measures from the 22 centimeter mark to the 50 centimeter mark, what is the length of the bone? Do the subtraction, figure it out, okay? And then, yeah, so just do it exactly as it's asking you to do there, okay? Now it says record the length of 2 bones. So I'll just give you the length of 2 bones. The first bone is 12 centimeters and the second bone is 25 centimeters, okay? Do the conversion, right? So that was for number 4 and for number 5 on page 11, okay? Hold on for 1 second. Excuse me, can you please be quiet? Thank you. Okay, all right, so now we're moving on to the next part of it, which is on page 11, down on the bottom there, for weight, okay? So metric units of weight, grams, right, milligrams. It says a paper clip weighs about 1 gram, and then it asks you to do some conversions. It asks you what's 2 grams, or how many milligrams are in 2 grams. You need to fill those in, okay? Now, for the experimental procedure for weight on the bottom of page 11, I don't have a scale, okay? I didn't bring the scale home from the lab. And again, it doesn't matter. I'm gonna give you a weight. So, you know, in lab, we use scales, right? To get these weight measurements in grams or milligrams, all right? So I could just take my item, place it on the scale, and I can tell you how much it weighs. So, so we're gonna get a wooden block that's small enough to fit into a graduated cylinder because it's gonna set us up for the next part. So here's my graduated cylinder, okay? And I had to cut an eraser to put that would fit inside, okay? So that's our object. We would weigh it. I'll tell you that it weighs 2.8 grams, okay? 2.8 grams, you're gonna write that in for number 2 under experimental procedure for weight. Right? And then you're going to figure out how many milligrams. All right, now, already did that. Oh, so this is the same thing. It's 2.8 grams, okay? I guess number 2 and number 3, just put the same answer there, 2.8 grams. All right, so again, as I told you, this is the 50 milliliter graduated cylinder that they're referring to in number 3 at the bottom of page 11. All right, so now we're moving on to page 12. Okay, and now we're going to talk about volume, right? So this graduated cylinder is one of the ways we measure volume, okay? And I apologize if it's kind of hard to see. Let me see if I can kind of get it. It's kind of hard to see the numbers there, right? But you can see in red there are volumes, right? So this is 10 milliliters, 20, 30, 40, 50, okay? And then you can see there's little tiny lines there that are just 1 milliliter each, okay? So this is what we would use to measure volume, okay? So if we wanted to measure 20 milliliters, we would pour liquid in there to that 20 mark, okay? All right, so I was mentioning milliliters, right? So we can talk about liters and milliliters. Okay, so there are 1,000 milliliters in a liter, okay? It tells you that on the top of page 12. That's where we are now. So experimental procedure for volume, okay? Let's see where we are. Okay, so that wooden block, which is really my eraser, I'm gonna measure the length, the width, and the depth for you, okay? In centimeters. And so the length is 2.8 centimeters, okay? The width is 1.5 centimeters, and the depth is 0.6 centimeters, okay? All right, so now you're gonna multiply those three numbers, right? And basically, you're gonna get centimeters cubed, okay? So we're gonna get the volume by multiplying length times width times height, and centimeters cubed is equal to a milliliter, okay? And so that's what this is telling you there, right? It's the same difference. So 1 cubic centimeter equals 1 milliliter. So whatever that volume is that you found out in cubic centimeters in number 1, that's the same number you're gonna put there where it says, therefore, in number 1 at the end, therefore the wooden block has a volume of what milliliters, okay? So milliliters are equal to cubic centimeters, right? So it's just asking you to make that, or figure out that relationship in your mind, in your head, and just write it down there, right? Okay, so and now we're on to number 2, okay? So take a minute to read number 2 if you need to on page 12. I said we usually will measure volume using graduated cylinder. I already told you that, okay? So now it says, fill a 50 ml graduated cylinder to the 20 milliliter mark, okay? So I'm gonna do that. I have green water. Hopefully it makes it a little bit easier to see. Oops, I did too much. Right, so just about right. All right, so I filled my graduated cylinder here to the 20 milliliter mark, all right? Now, again, it is kind of a little bit hard to see. I did use green water to make it a little bit easier, but I think maybe I need more light. So let's move over here. Maybe that's what the problem is. I'm just gonna move us. All right. Yeah, I think that helps. Okay, so if we look here, right? I think that helps a little bit. Anyway, you can see that I basically poured water in here, green water, and I poured it up to that 20 milliliter mark, okay? So if we're measuring 20 milliliters, what you wanna do is you wanna get eye level, and you're gonna see the water has this sort of dip in it, and you measure at the bottom of that, and that's called the meniscus, okay? So that's the proper way of measuring volume in the lab. And I will say this too, you also wanna make sure you have the appropriate size graduated cylinder, right? So if you only wanted to measure, say, 5 milliliters, this 50 milliliter graduated cylinder is not appropriate, right? You would use something smaller. Actually, there's a tool that you could use for that. I'll show you right now. Because part of this lab is also getting familiar with some of the lab, lab equipment too, kind of just not really sort of on purpose, but it is introducing you to these things as well. So if I wanted to measure 5 milliliters, okay, I can use something like this, which is called a seriological pipette, right? And so basically what I can do is I can put this in here. Sorry, let me pull this back a little bit, right? And I can basically draw up the liquid. We'll see. Okay, and I can draw it up to whatever known amount that I want, and this would be 5. Nope, I go all the way up to the 0 there. This would be 5 milliliters. Okay, so that's one way to measure 5 milliliters. You can also use a smaller graduated cylinder, like I said. Okay, so again, important to choose the appropriate piece of equipment or appropriate glassware to measure the appropriate volume. All right, so that's sort of a side note, I guess. All right, so we're still following along what we were doing before. We're on number 2 on page 12. Okay, we already did that, right? You measured that 20 milliliter. Now it says, pour the 20 milliliters of water into a test tube. I hypothesize how you could find the total volume of that test tube. So here's my test tube, okay? Here's my test tube. Hey, go this way. Here's my test tube. Here's my 20 milliliters of water that I measured. I actually forgot to check how much this holds. Ooh, we're lucky. All right, so I poured 20 milliliters into here. So here's my test tube now. So the question says determine, right? Come up with a hypothesis how you would figure out how much total this test tube holds. Meaning it's showing you 20 milliliters right now. How would you determine what the volume would be if I fill this all the way up? I'm not going to tell you. Figure it out. It's actually, there's a very simple answer to this. Sometimes we sort of come up with all these complex answers. It's not that complex. Just try to be simple about it. If I just said, how can you determine how much volume this entire test tube holds? How would you figure that out? Right? Using a graduated cylinder, using some liquid, some water. How would you figure that out? All right, so I'll leave you to that. We'll see what you come up with. And then it says, what is the test tube's total volume? So you're not gonna know that because I don't wanna tell you the answer of how you would do it. So don't worry about that. You'll leave that blank, all right? Just say how you would determine it though, all right? Tell me how you would determine it. Here's your graduated cylinder, here's your test tube, and you got water, all right? Okay, so we move on. Let me pour this back in here so that I don't spill it. Okay, my green water goes back in here. Maybe that gave you a clue as how to figure it out. Anywho, okay. So now we are moving on to page 13, okay? So now we're on number 4 on the top of page 13. It says, fill that graduated cylinder with water to about the 20 mil mark. I already did that, okay? It says, hypothesize how you could use this setup to calculate the volume of an object, okay? So remember we had our object here that we determined the volume, right? If, I'll kind of tell you, I guess, the answer to this one. It's saying, all right, you have this liquid in here. You know it's at 20 mils, right? Remember we, in the beginning of, of this exercise for volume, we measured the length, the width, and the height of this, right? And we determined that that is equal to the volume in milliliters, right? That cubic centimeters is equal to milliliters, okay? So whatever answer you got there, you know this volume. Well, what if we didn't do that and we just had this and this and you didn't have a way of measuring it? What's another way of determining the volume of this, right? You can basically just put this in here. So we know it started off with the 20. We drop that in, and now I see that the water level raised up to 24, okay? So now you can answer that. It says the object, which is our eraser, right, has a volume of what? It started off at 20 milliliters. When I dropped that eraser in, the water level rose to 24 milliliters, okay? So what is the volume? And then you can kind of compare it back to what you did when you multiplied, right, if you want. All right, so that's for number 4 on page 13. Now we're on to number 5. It says hypothesize how you could determine how many drops from the pipette of the dropper bottle equal 1 mil, right? So how would you figure that out? Think about it. Yeah, so you basically want to know if I had a dropper like this, right? How many drops, little drops like this, I'll show you, right? Little drops, meaning you have to do it slow. 1, see my little drops, 2, 3. You want to know how many drops equal 1 milliliter. How would you figure that out? Write down, hypothesize how you would, again, using a graduated cylinder, using your dropper, how would you determine that? Okay, how are you going to come up with how many drops equal 1 milliliter? All right. Okay. So it says now perform the operation you suggested. You're not going to be able to do that. That's fine. Again, I want you to just tell me how you would do it. Okay, so you're sort of skipping that second question for number 5, unless you have graduated cylinders at home and you can figure it out. All right, number 6. Okay, it says some pipettes are graduated and can be filled to a certain level as a way to measure volume directly. So if you guys, you're not gonna be able to see this, maybe. You can kind of see there's little lines on here, okay? See that here? What am I doing here? There's little lines on here that you can see kind of, and that's graduated. So this is 1 milliliter here, right? So this would be 0.25 milliliters, 0.5, 0.75, and 1. So you can actually use this to estimate the volume, right? To sort of measure it directly. Is it the most accurate way? Definitely not, okay? But if you kind of need just like about 1 milliliter, you might want to just do this, okay? What's an exact way of measuring like 0.25, 0.5, or 1 milliliter? I'll show you what we're going to use them later in the semester. It's using a micropipette, okay? So, and you've probably seen lots of pictures of people using these. Maybe you've used them before, but it's a micropipette, right? So this measures small volumes. So volumes less than a milliliter, okay? So like I said, we'll talk about these later in the semester. You know, if we were live, you guys would have a chance to use these, but as you move on, you'll have a chance to use them. Okay. All right, so that's it for the volume, okay? We finished page 13. The next part is temperature, all right? We were on page 14, temperature, and basically we're talking about converting, you know, temperatures from Fahrenheit, which is the way we refer to temperature in the United States, to Celsius. So when we're talking about temperature in the laboratory, it's always in degrees Celsius, okay? So basically you can answer all of these questions without any information from me up to number 3, okay? Number 3, it says record some temperatures. Now, you may not have a thermometer, okay? Maybe you do. So if you have a thermometer and you can measure your body temperature, so you're not gonna do these measurements that are listed here. I mean, again, if you want to and you have a means of doing that, you can, but what I want you to do is basically just write in 2 additional temperatures. So body temperature, if you have a thermometer, take your temperature, okay? Write it down in Fahrenheit and then convert it to Celsius, right? Or it just asks you in Celsius, so whatever, you have to do the conversion. And then the other thing is, here's what you can do if you don't have a thermometer, right? Watch the weather, look on your iPhone, see what the temperature is outside today, and put it into Celsius. Now that's easy because you can just have your phone give you the temperature in Celsius, but whatever, okay? So outside temperature in Celsius. If you have a thermometer and you want, you can measure some other temperatures as well, but we want them in Celsius. All right, so that is it for that portion of the lab. So we will now move on to microscopy, if I could say it. And like I said, what I'm going to do is I'm going to show you the, you know, what's in the microscope with my phone. So you know what? I'm going to end this meeting and I'm going to start a new recording. So we have 2 separate videos. So this was for the metric system part of it and really using laboratory glassware, right? We talked about measuring volumes using graduated cylinder. I also showed you a transfer pipette. That's what this is called. I also showed you a seriological pipette, right? And then the micropipette as well, right? Another thing, I might as well kind of point this out too. This is a flask, right? And you can see that this has graduations on it too. So you still can measure volume using this. This is not as accurate as a graduated cylinder, okay? You also have beakers in the lab as well. Same thing, they're gonna give you, you know, estimations of volume on there, but not really an accurate way of measuring exact volumes. You would wanna use that graduated cylinder like we did, okay? And we talked about converting as you moved through. All right, so like I said, I'm gonna end this. I will start a new recording for the microscope part of this lab.